All right, good morning and welcome to Master Talker online class. In today's video, we'll be talking about the theory and the application of complex number. All right, so we'll be solving question 188. Question 188 said express express 3 plus 2i into 4 plus I in in form form a plus bi. Okay, solution. It simply means to open this bracket. So I have 3 plus 2i into 4 plus I. So if you open the bracket, you see 3 times 4, 12. 3 times this, 3i. This time this, 8i. 2 times invisible 1 is 2, and I times I is minus 1. So I'm going to have 12 minus 2 will give you 10, plus this and this will give you 11i. So A is equal to 10 and B is equal to 11. So that is that. Option C is correct. Question number 189. Question number 189 said evaluate I raised to power 265. Okay, so now the shortcut to get this is what? If you have I raised to power n, okay, you now say that if n is even, then the answer you'll be expecting is either I squared is minus 1, so either 1 or minus 1. I don't know how to start explaining it for you, but first of all, 2 4 265 265 is an odd number. Since it's an odd number, I'm expecting I or minus I as my answer. All right, so when I divide this by 265 divided by 2, I will take the whole number part. 265 divided by 2, I'm having 2132. I'm having 132.5, but I don't need that point, which is equal to an even number. So if it's an even number, I'm taking the positive side. So the answer to this is what? Is I. The answer is simply I. Or if you want to solve it, you have that I raised power 265 is equal to I raised power, divide this by 2. I'm going to have I'm going to have 2 times 132, then plus 1. Okay, let's check it out. 132 times 2, then plus 1. So you now have that what? This is I squared all raised power 132. Okay, let me share it for them. Let me share it. I raised power 2 into 132 times I raised power 1, which is what? I squared all raised power 132 times I raised power 1. I squared is minus 1 all raised power 132 times I, which is equal to what? 1 times I, which is equal to I. So the same thing, the same answer that I got here. So let's go to question number 190. Question number 190. Question number 190 said express 1 plus I all over 2 plus 5I in the form A plus BI. Okay, this simply means we should rationalize. So I have 1 plus I all over 2 plus 5I times 2 minus 5I over 2 minus 5I. So this is equal to 1 times 2 is 2. 1 times this minus 5I. I times this, I have plus 2I. Plus times minus 5 into minus 1. Okay, my 1 times minus 5 minus 5. I times I is minus 1 all over. For the denominator, simply the first time the first minus the second time the second. So the first time the first will give you 4. Plus times minus is minus. 5 times 5 is 25. Why I times I is minus 1. So I'm going to have this, and this is giving me plus 5. 2 plus 5 is 7. So I have 7 here. This and this is giving me minus 3I all over. This and this is giving me 29. So this is what? 7 over 29 minus 3 over 29I. Okay? Very, very simple. So we move to question number 191. Question number 191 So 191, question number 191 said the principal argument principal argument of 1 minus I. The principal argument of 1 minus I is dash. Okay, want to get the principal argument of 1 minus I. Now, how do you get the principal argument? Now, in principal argument solution, they gave us that z is equal to, that z is equal to x plus yi, so which is equal to 1 minus I, which shows that what, x is equal to 1, which is what, which is greater than 0, and y is equal to what, minus 1, which is less than 0. So according to principal argument, if x is positive and y is negative, so the principal argument is simply normal argument. I think if x is positive, principal argument is equal to normal argument. So we now have so to get the normal argument, I know that theta is equal to what, the tan inverse of what, y over x, which is what, the tan inverse of so the absolute value of y minus x. So absolute value of y minus x. So what's the absolute value of that? Is minus 1 over 1. So which is what, the tan inverse of 1. Okay, and what is the tan inverse of 1? Tan inverse of 1, shift tan 1, I think 45. Yes, 45 degrees. And 45 degrees, convert it to radian, you are going to have 45 times pi divided by 1/8. So which is what, divided by 1/8. So I have pi over 4. Let's check. I think you are supposed to subtract pi. Let me check principal argument. Okay. So the principal argument here, if x is greater than 0, then it's normal argument. If x is less than 0, okay. So this is the principal argument for pi over 4. Pi over 4 is very, very correct. So the principal argument is it's same as normal argument. So which is the tan inverse of y over x. Are we taking absolute value? Are we taking absolute value? Okay, we're not taking absolute value here. So the principal argument is that is tan inverse of minus 45. That is minus pi over 4. Okay, minus pi over 4. So we're not taking the absolute value. We're just taking this. So which is minus 45. So let's move to the next one. Question number 192. Question number 192. 192. Question number 192 said the polar form. The polar form of the root of 3 plus I is dash. Solution. Anytime you want to find polar form, first thing you need to find is the modulus. Modulus is equal to the square root of root 3 all squared plus 1 squared, which is what? The square root of, because here my x is equal to root 3 and my y is equal to the coefficient of I, which is 1. So I'm going to have 3 plus 1, which is root 4, and root 4 is 2. Then the next thing I need to get is my argument, which is theta. Theta is the tan inverse of y over x, which is what? The tan inverse of my y is 1 all over root 3. Tan inverse of 1 over root 3 is 30 degrees. So the polar form is z is equal to r in bracket of cos theta plus I sin theta. Okay, so which is what? 2 in bracket of cos 30 plus I sin 30. So this is the polar form. So we go to the next question. Question number 193. Question number 193. Question number 193. Okay, out of how many questions? Almost 231. Hey, problem. Okay, 193. I have express. They said express 3 minus 2i and 4 minus I in form of a plus bi. Solution: just open this bracket. 3 minus 2i all over 4 minus I is equal 3 times 4, 12. 3 times this minus 3i. This time this minus 8i. Minus times minus plus. 2 times invisible 1 is 2. I times I is minus 1. So I'm having 12 minus 2 is 10. Minus this will give you minus 11i. Very, very simple. Question 194. Question number 194 said the modulus and the principal argument of they say the modulus and the principal argument of 1 minus I are okay. So we have gotten the principal argument here as minus pi over this. So what we need is just the argument, the modulus. R is equal to the square root of x squared plus y squared, which is the square root of 1 square plus minus 1 square, which is what? The square root of 1 plus 1, which is the square root of 2. 1 plus 1, which is what? Root 2. So we have root 2, comma, minus pi over 4. Okay? Root 2, comma, minus pi over 4. So that is that. So we move to the next question. Question number 195. Question number 195 said simplify 1 minus 10 all raised to power 10. Okay, sorry, 1 minus I all raised to power 10. Okay, solution: the first thing we need to get is the what? The modulus. Okay, the modulus. And the modulus is simply r, which is what? The square root of x squared plus y squared, which will give you the square root of 1 squared plus minus 1 squared, which is equal to what? Root 2. The next thing we need to get is theta. Theta is equal to what? The tan inverse of the, okay, we even gotten theta. We got theta as minus 45 from here. Our theta is equal to minus what? 45 degrees. If you convert it to plus, you have minus 45 plus 360. Let it be positive. That is 310, 330, 315. Sorry. Okay. So I have that my z is equal to what? R into cos theta plus I sin theta. All right. So my z is equal to what? Root 2 in bracket of what? Cos 315 plus I sin 315. So but z raised power n is equal to r raised power n into cos n theta plus I sin n theta. Okay, so if you now put it, you have that z raised to power 10. Okay, z raised to power 10 is equal to what? Root 2 raised to power 10 in bracket of cos 10 times 315 plus I sin 10 times 315. Okay, so I'm going to have 2 raised to power 5, that is 32, in bracket of cos 3150 plus I sin 3150. So if you now use your calculator to get that, you'll be having, so I have that my z raised to power 10 is equal to 32 in bracket of cos 3150. I'm having 0, so having 0 here plus sin 3150. I'm having minus 1, so into minus 1, so I. Okay, so which is what? This time this will give you minus 32i. Minus 32i is very, very correct. So question number 195, minus 32i. Okay, so we move to the next question. Question number 196. Question number 196 said the modulus and the principal argument of, sorry, I've done that. 196 said the polar form, the polar form of minus root 3 minus I is dash. Solution. The first thing we get is what? The modulus. The modulus R is equal to the square root of x squared plus y squared, which is the square root of minus root 3 all squared plus what? Minus 1 squared, which is the square root of 4. Okay? And the square root of 4 is what? 2. So we have gotten the modulus. The argument is now theta is equal to the tan inverse of what? Y over x, which is what? The tan inverse of minus 1 over minus root 3, which is equal to what? 30 degrees. So the polar form Z is equal to what? R cos theta plus what? I sin theta. So which is what? 2 in bracket of cos 30 plus I sin 30. Very, very simple. We move to the next one. 197. Question number 197. 197. Question number 197 said express 1 plus I all over 2 minus 5I in form A plus BI. Just rationalize. Solution. So if you rationalize, I'm going to have that 1 plus I all over 2 minus 5I times 2 plus 5I, 2 plus 5I over 2 plus 5I. So if you multiply 1 times everything is the same thing, 2 plus 5I. So I times this will give you what? 2I. I times this will give you what? Plus into 5 into minus 1 all over 2 times 2, 4. Minus times plus minus 5 into minus 1. So what do I have? This and this is giving me minus 3. Okay? Plus 7I all over 9. So I'm having minus 3 over 9 plus 7 over 9I, which will give you minus 1 over 3 plus what? 7 over 9I. So that is that for that. So move to the next question. So there is an error there. That thing is not 29 but 9. So it's a typographical error. So move to the next question. Question number 198. 198. Question number 100 said the principal argument of the principal argument of minus 1 minus I. The principal argument of minus 1 minus I is solutions. Now, first of all, we have that Z is equal to minus 1 minus I. We show that X is equal to minus 1 and my Y is equal to minus 1. So whenever X is negative and Y is negative, the principal argument, principal argument is equal to normal argument minus pi. Okay? Normal argument minus pi. So let's do that. To get normal argument, theta is equal to what? The tan inverse of what? Y over x. So which is what? The tan inverse of minus 1 over minus 1. Which is what? The tan inverse of what? 1. Which is equal to again 45. And 45, convert it to radian, you have times what? Pi over what? Over 180. So which is what? Pi over 4. Okay? So I have 45 divided by 180. So pi over 4. So the principal argument will now be what? Pi over 4 minus pi, which will give you 3 pi minus 3 pi over 4. Minus 3 pi over 4 is the principal argument. So the next question, number 18. So number 201. Question number 201 said one of the roots of minus 4 is one of the roots of minus 4 is dash. Okay, one of the roots of minus 4 is simply, okay, let us get the root. the root of minus 4. Solution, we have that z is equal to what? Minus 4 plus 0I. Okay, so to get our modulus, r is equal to the square root of minus 4 all squared plus 0 square, which is equal to what? The square root of 16, which is equal to 4. Okay, so we now need the theta. Theta is equal to the tan inverse of y over x, which is equal to what? The tan inverse of 0 over 4, which is tan inverse of 0. Tan inverse of 0 is 0. Okay, if tan inverse of 0 is 0, so we are going to have that z is equal to r cos theta plus I sin theta. So which is equal to what? 4 in bracket of cos 0 plus I sin 0. Okay, so what do we have now? Z raised to power, one of the roots. Okay, the root of this, or this is even I'm even going too far. The root of minus 4, the root of minus 4 is simply plus or minus the square root of minus 4, which is equal to what? Plus 2I or minus 2I. That's the root of that. No need to even go far. So they made mistake. It's not, their own is not correct. 202. This is the root of this. So one of it is either this or this is one of the roots. So they gave us that if z is equal to 3 plus, sorry, 2 plus 3I all over 3 plus 4I. Okay, then I say then we should find the real part of z. The real part of z. So solution, what do we do? To get the real part of z, we need to rationalize this. So I have 2 plus 3I all over 3 plus 4I times 3 minus 4I over 3 minus 4I. So which will give you 3 times 2, 6. 2 times this minus 8I, 3 times 3 plus 9I, plus times minus minus 3 times 4, 12. I times I minus 1 all over 3 times 3, 9. 4 times 4, 16. I times I minus 1. So what do I have? I'm going to have that this is equal to 6 plus 12 is 18. So I have 18. This and this is 1. 18 plus I all over 25, right? 9 plus 16, 25. 9 plus 16, 25. So I have 25. So I have what? 18 over 25 plus 1 over 25I. So the real part of z is equal to what? 18 over 25. The one that does not have I is called the real part of z. So that is that. Question number 202. Question number 202. Okay, question number 202 said, okay, the one I solved now is 202, sorry. The one I solved now is 202. So let's go to 203. 203 said the principal argument of I raised to power 126. 126 is solution. So what do we do? I raised to power 126 is equal to what? I divided by 2. 126 divided by 2. I have 63. I raised to power 2 all bracket 63. 2 times this will give me this. But I know that I squared is minus 1. Minus 1 raised to power 63 will give me minus 1. Okay? So I have minus 1 as an answer. So z is equal to what? Minus 1 plus 0I. So which shows that x is equal to minus 1 and my y is equal to 0. So in principal argument, whenever y is equal to 0, whenever x is negative, okay, x is negative and y is 0. So we're going to take the principal argument is now the principal argument is equal to what? Theta plus pi. Okay, theta plus pi whenever x is negative and y is 0. So if x is 0, then okay, so what do we do to get the principal argument? Normally is what? The tan inverse of y over x, then plus my pi. So what do I have? The tan inverse of my y is 0 and my x is minus 1. So tan inverse of 0 is 0. So it means whenever y is 0, the principal argument is simply pi. Okay, whenever y is 0, the principal argument is simply pi. So let's just finish it. Tan inverse of this is 0 plus pi, which is what? Pi. So whenever y is 0, the principal argument is pi. So let's go to question number 204. Question 204. Question number 204 said express in polar form. Express 1 plus I in polar form. Solution. So the first thing to get is your r, which is what? The square root of x squared plus y squared, which is what? The square root. If you have not watched my video on complex number, please do that. That's why I'm rushing this, so that it will help you. You've already known what to do. So 1 square plus 1 square, which is what? The square root of 2. So the next thing is theta. Theta is equal to the tan inverse of y over x, which is what? The tan inverse of 1 over 1, which is what? Theta is equal to the tan inverse of 1, which is what? 45. So z is equal to r in bracket of cos theta plus what? I sin theta. So which is equal to what? Root 2 in bracket of cos 45 plus I sin 45. Okay, you see that this is very, very simple. That's your polar form. So the next one, question number 205. Question number 205. Question number 205 said, they say given that z1 is equal to minus 1 plus 3i, and z2 is equal to 2 plus 5i, then I said then the modulus of z1 minus z2 is dash. Solution. The first thing you need to get is z1 minus z2. So z1 minus z2 simply means z1 is minus 1 plus 3i minus z2, which is 2 plus 5i. Okay, which is what? Minus 1 plus 3i minus 2 minus 5i. This and this is giving me minus 3. This and this is giving me minus 2i. So the modulus of z1 minus z2 is simply the square root of minus 3 all squared plus minus 1 minus 2 all squared. So what do we have? The square root of 9 plus 4, which is what? The square root of 13. So the answer is root 13. Root 13a is the correct answer. We move to question number 206. Question number 206. So 20, okay, there's no 206, we have 207. Question number 207 said the modulus and the argument, the modulus and argument of 1 plus I is solution. We did it before. So the modulus is simply r, which is what? The square root of 1 square plus what? 1 square, which is what? Root 2. Then the argument theta is equal to what? The tan inverse of what? Y over x. So which is what? The tan inverse of 1 over 1, which is what? The tan inverse of 1, which is what? 45 degrees. Okay, so very, very simple. And 45 degrees simply means pi over 4. That is 45 times pi divided by 1/8, which is what? Pi over 4. So that is the what? The argument. So question number 208. Question number 208. Okay, there is no 208, no 209, 210. Question number 210 said, obtain the modulus, the argument, and the principal argument of the complex number. Okay, permit me to refill. Okay, they say obtain the what? They say question 210, obtain obtain the modulus, comma, argument and the principal argument of z equal to what? Minus root 3 minus I. Okay? Solution. First of all, the modulus r, the modulus of z, which is equal to r, is equal to the square root of x squared plus y squared. So which is what? The square root of minus root 3 all squared plus minus 1 all squared. Okay, so I'm having the square root of 9 plus 1, which is what? Okay, square root of 3 plus 1, which is root 4. Root 4, which is equal to 2. Okay, that is my modulus. Then the argument theta is equal to what? The tan inverse of what? Y over x, which is what? The tan inverse of my y is minus 1, my x is minus root 3. So which is what? The tan inverse of 1 over root 3, which is equal to what? 30, which is 30. And 30 is the same thing as what? Times pi over 180, which is what? 180 divided by 30. So I have 6. So I have pi over 6. Pi over 6 is the argument. But the principal argument is plus pi, minus pi. So the principal argument is what? Normal argument minus pi, which is what? Normal argument is pi over 6 minus pi. So what do you have? Minus 5 pi over 6. Very, very simple. We move to the next question. So watch my video on complex number so that you can get all these things I'm saying here. So question number 212, 212. Okay, I have solve the equation 3z minus 2z bar, which is equal to minus 1 comma, so minus 1 plus 15i. Okay, solution. So what do we do? So we are asked to find z, that's the meaning. So I have that 3z minus 2z bar is equal to minus 1 plus 15i. Okay, minus 1 plus 15i. So now what is my z? First of all, z is equal to s plus yi. Y my z bar is equal to x minus yi, the conjugate. So let us put it 3 in bracket of s plus yi, okay, minus 2 in bracket of x minus yi, okay, is equal to minus 1 plus 15i. This time this will give you 3x, this time this will give you plus 3yi. Okay, this time this will give you minus 2x, this time this will give you plus 2yi is equal to minus 1 plus 15i. So this and this will give me x, this and this will give me plus 5yi is equal to minus 1 plus 15i. So compare, if I compare, you will see that x is equal to minus 1 and 5y is equal to 15. Therefore y is equal to 15 divided by 5, which is 3. So but I know that my z is equal to x plus yi. So z is equal to minus 1 plus 3i. Very, very simple. We move to the next question. Question number 213. Question number 213. Question number 213. 213. Question number 213 said the polar form of minus root 3 over 2 minus I over 2 is solution. Before you find polar form, I need the modulus. R is now the square root of what? S squared plus y squared, which is equal to the square root of minus root 3 over 2 all squared plus minus 1 over 2 all squared. So what do we have? We have that this is the square root of 3 over 4 plus 1 over 4. So I have the square root of 3 plus 1 over 4, which is the square root of 4 over 4, which is the square root of 1, which is equal to 1. So that is my modulus. Then my argument, theta. Theta is equal to what? The tan inverse of y over x, which is what? The tan inverse of my y is minus 1 over 2 divided by my x is minus root 3 over 2. So what do I have? We now have that theta is equal to the tan inverse of minus 1 over 2 times minus 2 over root 3. So this take care of this. I have tan inverse of 1 over root 3, which is equal to 30. So my z is equal to r in bracket of cos theta plus what? I sin theta. So what do you have? I got 1 in bracket of cos 30 plus what? I sin 30, which is simply cos 30 plus I sin 30. So that is that. We move to question number 214. Question number 214. 214. Question number 214 said the polar form of I raised power 1 over 3 is, okay, the polar form of this. Solution. First of all, this is z is equal to 0 plus I, then raised power what? 1 over 4. Sorry, 1 over 3. Okay, so my r, first of all, modulus is what? The square root of x squared plus y squared, which is the square root of 0 plus 1 square, which is the square root of 1, which is 1. Okay, then my theta is equal to the tan inverse of y over x, which is what? The tan inverse of my y is 1 over 0. So the tan inverse of undefined is 90. Okay, tan inverse of undefined is 90. So I have that my z is equal to r in bracket of cos theta plus what? I sin theta. So I have that what? My r is 1 in bracket of cos 90 plus I sin 90. So which will simply give you cos 90 plus I sin 90. All right. So z raised power 1 over 3. You need to know a formula that says that z raised power 1 over n is equal to, what am I saying? R raised power 1 over n into cos 2 pi 2 pi r 2 pi k or 2k pi 2k pi over n 2k pi over n plus I sine 2k pi 2k pi over n. Okay, or theta plus 2k pi over n. Sorry, let me get it right. So 1 over this into cos theta plus 2k pi over n plus I sine theta plus 2k pi over n. Okay, where k is simply 0, 1 and 2, because I have 3 here, up to n minus 1. So in this case, k is going to stop at 2. So when k is equal to 1, so z raised power 1 over 3 is equal to what? 1 raised power 1 over 3 into cos 90 plus okay, when it is 0, sorry, when it is 0, so everything here is 0, so it will now be plus 0 all over my n is 3 plus I sine the same 90 plus 0 over 3. So here I'm having n to the raised power 1 is the same thing, so I have cos 90 divided by 3 is 30. So I have 30. So I have 30 plus what? I sine 30. This is the first one. So when k is equal to 1, I have that z raised power 1 over 3 is equal to what? 1 raised power 1 over 3 into cos 90 plus, if I put 1 here, 2 times 1, 2. 2 times pi is 180. 2 times 180 is 360. So 360 all over what? 3 plus I sine 90 plus 360 over 3. So I'm going to have this is cos, n to the raised power 1 is the same thing. So I'm going to have 360 plus 90, then divided by 3. So I have 150, cos 150 okay, plus I sine 150. So the last one is when k is equal to 2. So I have that z raised to power 1 over 3 is equal to I raised to power 1 over 3 into cos 90 plus 2 into 2 pi all over 3 plus I sine 90 plus 2 into 2 pi all over 3. So finally, I'm going to have z is equal to cos, let's do that, 2 times 2 times 180 plus 90 divided by 3. I have 270. So cos 270 plus I sine 270. So these are the polar form of that complex number. So we move to the next one. Express this in standard form. Question number 215. 215 said express 215 say express root 2 in bracket of cos pi over 4 plus I sine pi over 4 in standard form. So what do you do? Solution. I have the square root of 2 in bracket of cos pi over 4 plus I sine pi over 4. So this is equal to root 2 in bracket of pi is 180. So 180 divided by 4. I'm going to have 45. So I have cos 45 plus I sine 45. So which is what? Root 2 in bracket of what? 45 is root 2 over 2 plus I root 2 over 2. So open bracket, this time this is 2. Okay, 2 divided by 2 is 1. So I have 1 plus I. So this is the standard form, 1 plus I. So the next question, question number 216. Question number 216. Question number 216 said the principal argument of minus root 5 is solution. I have that z is equal to minus root 5. Okay, minus root 5 plus 0i. And I told that if y is equal to 0, the principal argument is simply pi. Whenever y is 0, the principal argument is pi. Very simple. Question number 127. Okay, question number 127 said solve the equation 2z minus z bar is equal to I plus 3. Okay, solution. I know that my z is equal to x plus yi and my z bar is equal to x minus yi. So put it here. I have that 2z minus z bar is equal to I plus 3. So 2 into x plus yi minus into x minus yi is equal to I plus 3. So what do we have? This time this 2x plus 2yi minus x plus yi is equal to I plus 3. So if you look at this now, you see that this and this is giving me x. Why this and this will give me plus 3yi is equal to I plus 3. Comparing this, x is equal to 3, the one that does not have I. So x is equal to 3. And then 3y that has I is equal to the coefficient here is 1. So my y is equal to what? 1 over 3. So therefore, my z z is equal to x plus yi. So z is equal to my x is 3 plus what? 1 over 2, 1 over 3i. So that is that. Question number 167, 127, 117, sorry. My battery is about to die. 217. 217 said, okay, we just solved 217 now, please. So 218 said if z is equal to 1 minus 5i, Okay, so if z is equal to this, bring my power bank for me. Okay, and w is equal to 3 plus 2i. Then I say express, they say express as complex with type c code as complex number in form x plus yi the following, and the following they gave us is 3. Okay, they gave us z bar w all over 3 plus I. Okay, no, type c code. Okay, solution. So I'm having my z bar is simply the opposite of this. So z bar is simply 1 plus 5i. Okay, so z bar w simply means 1 plus 5i in bracket of 3 plus 2i, then all over 3 plus I, all over 3 plus I. So I'm having this time this is 3, this time this is 2i, this time this is 15i, this time this is plus 10 in bracket of minus 1 all over 3 plus I. Okay, so this is going to be this, and this is 7. So I have minus 7 plus 17i all over 3 plus I times 3 minus I over 3 minus I. So I'm going to have, is it charging? Please, 1 minute. Okay, please leave it to avoid problem. So let's open the minus 3 times this is 21, minus 21, sorry, minus 21, minus 3 times this will give you plus 7i. This time this will give you 17 times 3 will give you 51. So plus 51i. This and this will give you plus 17, plus 17 all over. This and this will give me 9, 9 plus 1. So I have minus 21 plus 17. I have minus 4. Minus 4, 7 plus 51. I have 58 plus 58i all over 10. So I'm having minus 4 over 10 plus 58 over 10i. So I have minus 2 over 5 plus 58 divided by 2. I have 29. 29 over 5i. So that is the complex number. So we move to the next one. We'll move to the next one. Question number 219. Question number 219 said, obtain one of the roots of this. Okay, we have done this before. Obtain one of the roots of 1 plus I raised to power 1 over 3. So that time we are asked in question number, okay, let's just do it. Solution, they say we should obtain one of the roots of this, okay. So first of all, we need the modulus. The modulus is simply the square root of 1 square plus 1 square, which is the square root of 2, okay. Then the argument theta is equal to the tan inverse of what? 1 over 1, which is the tan inverse of 1, which is what? 45 degrees. So the polar form z is equal to what? R in bracket of cos theta plus what? I sin theta. Okay, so which is what? The root 2 all raised power what? Okay, root 2 in bracket of what? Cos 45 plus what? I sin 45. Right? So what do we do now? We're going to say then z raised power 1 over n is equal to what? R raised power 1 over n in bracket of cos theta plus 2 pi k, 2k pi or 2 pi k, anyone, 2k pi all over n plus I sine theta plus 2k pi all over n. Okay, so let's do that now. So I'm going to have z raised to power 1 over 3 is equal to root 2 raised to power 1 over 3 into cos 45 plus 2 into, now k here will start from 0, 1 and 2. Okay, so one of that, did they give us, mom, come and carry your son before kwatoru me here. Hi. So o shake your karaoke. Okay, so I have so one of the roots of this, becomes so they say 1, so let me say the one that has 0. Okay, let's say the one that has 0. Sorry about that. So they say just 1, so let me say when k is 0, when k is equal to 0, I'm going to have z raised to power 1 over 3 is equal to root 2 raised to power 1 over 3 into cos 45, plus everything here is 0, so cos 45 divided by 3, okay, plus I sine 45 divided by 3. Okay, so what do we have now? So I'm going to have z raised to power 1 over 3 is equal to the square root of 1 over 3 here into 45 divided by 3. 45 divided by 3. I have cos 15. So I have cos 15 plus I sine 15. So which is what? The square root of raised to power 1 over 3 in bracket of cos 15. Cos 15 is what? Root 6 plus root 2 over 4 plus the same sine 15. We have root 6 minus root 2 over what? Over 4i. So that is that. So this is one of the roots. Okay, you can decide to choose when k is 1 by yourself and when k is 2. So they are going to be 3 in number, so but they say we should find one of them. So this is the answer to just one of them. So we'll go to question number 220. Question number 220. Okay, question number 220 said, what is the value of, they say what is the value of 1 minus I raised to power 4? Okay, solution. I can decide to say that 1 minus I raised to power 4 is same as saying 1 minus I. If I don't want to use polar form to solve it, all square, then raised to power another 2. Okay, and this thing all square, let me create the inside. Square the first one 1, multiply the first one and the second one, double it, minus 2i, square the last one. I have minus here and minus 1. Okay, so which is what? This and this will give me 2. So I have 2 minus 2i all squared. Square the first one again, 4. Multiply this and double it. I have minus 8i. I hope I'm not making mistake anyway. Okay, square this one is, okay, so this is plus. So which will give me inside there, this and this is gone. So I have minus 2i left, all squared, which will give me 4 into minus 1. So which is minus 4. So my answer there is minus 4. Or you can do your own like this. 1 minus I all raised to power 4 is 1 minus I into 1 minus I into 1 minus I into another 1 minus I. If you open this thing, you will still get the same answer. Or you use polar form to solve it. You can equally use polar form to solve it if you like. Right? So it depends on the one you choose to do, but the answer is minus 4. So the next one, question number 221. Question number 221 said, express express root 3 plus I all over root 3 minus I in polar form. In polar form. Okay, first of all, you need to rationalize. So if you rationalize, I'm going to have root 3 plus I all over root 3 minus I times root 3 plus I over root 3 plus I. So root 3 times root 3 is ordinary 3. Root 3 times I is what? I root 3. This time this is another I root 3. This time this will give you minus 1 all over. This time this is ordinary 3. Minus times plus is minus. I times I is minus 1. So I'm having this, and this will give me 2 plus 2I root 3 all over 4, which is what? 2 over 4 plus 2I root 3 over 4. So which is what? 1 over 2 plus um, root 3 over 2I. Okay, so this is the, so to get the polar form we need the modulus and the argument. The modulus r is equal to the square root of x squared plus y squared, which is the square root of 1 over 2 all squared plus root 3 over 2 all squared, which is what? The square root of 1 over 4 plus 3 over 4. Okay, so which is what? The square root of 4 over 4, which is what? Square root of 1, which is 1. So this is the modulus. So the argument theta is equal to the tan inverse of y over x, which is what? The tan inverse of my y. My y is root 3 over 2 times 2 over 1. So if you change divide to times, this take care of this. I have the tan inverse of root 3, which is equal to 60. So the polar form becomes z is equal to r cos theta plus I sin theta. Don't forget. So my r is what? 1 in bracket of cos 60 plus I sin 60. So that is that. Cos 60 plus I sin 60 is the polar form. So we move to the next question. Question number 222. Okay, there is no 222. We have 223. Question number 223. Let me quickly refill. Question number 223. Question number 223. Okay. Question number 223 said. Question number 223 said. Let z1. Let z1 be equal to. Let z1 be equal to 6 into cos pi over 3 plus I sin pi over 3. Okay, and z2 will be equal to 2 in bracket of cos pi over 4 plus I sin pi over 4. Then they now say that we should find z1 over z2. Okay, first of all, solution. Our z1 is equal to 6 in bracket of cos pi means 180. So 180 divided by 3. So I'm going to have 60 cos 60 plus I sin 60. Okay, so which is what? 6 in bracket of cos 60 is half plus sin 60 is root 3 over 2 I. So if you multiply this time, this will give you 3 plus what? 3 root 3 I. Okay, so let's go to z2. Z2 is equal to what? 2 in bracket of 180 divided by 4. 180 divided by 4. I have 45. So which is what? Cos 45 plus I sin 45. So what do we have? 2 in bracket of cos 45 is what? Root 2 over 2 plus I sin I root 2 over 2. So what do we have now? That my z2 will now be equal to what? 2 times this will give you what? Root 2 plus what? I root 2. Okay, so my z1 over z2 simply means z1 is what? 3 plus 3 root 3 I Okay, 3 plus 3 root 3i all over what? Root 2 plus root 2i. Then you times root 2 minus root 2i all over root 2 minus root 2i. So let's multiply. This time this will give you 2 root 2. Sorry, 3 root 2. This time this will give you minus 3 root 2i. This time this will give you plus 3 root 6i. This time this will give you 3 times this is minus 3. Root this times root this is root 6. I times I is minus 1. So which will make this place plus. All over. The first times the first is 2. The second time the second will give you minus 2 into minus 1. So which will give you 3 root 2 minus into 3 root 2 minus 3 root 6 I. Okay, or let me write it very well. So this is 3 into root 2 plus root 6, okay, minus 3 into root 2 minus root 6 I, or let me say 3i into this, then all over what? 4. So that is there. You can separate it now to have 3 over 4 into root 2 plus root 6, then minus 3 over 4 into root 2 I here minus root 6. So that is that. So we'll move to question number 224. Question number 224. 224. Question number 224 said that question number 224 said if z is equal to cos theta plus I sin theta. So they now say then we should find z raised to power k plus 1 over z raised to power k. Okay, first of all, z raised to power k is equal to what? Cos k theta plus I sin k theta. So 1 over z raised to power k means z raised to power minus k, which is equal to what? Cos minus k theta plus I sin minus k theta. Okay, and cos is an odd function, so this is cos k theta minus I sin k theta. So if you add the two of them now, so zk plus 1 over zk is equal to what? Cos k theta plus I sin k theta. Okay, plus cos k theta minus I sin k theta. So this and this is gone. This and this will now give you 2 cos k theta. Very, very simple. 2 cos k theta. So we move to the next question. Question number 225. Question number 225. Okay, there is no 225 but 226. 226. Question number 226 said that if a squared plus b squared is equal to 1, comma, then the imaginary part of z, that we should find the imaginary part of z for z is equal to 1 plus b plus ia all over 1 plus b minus ia. Okay, so to do this is simply to rationalize solution. So I'm having that 1 plus b, okay, plus ai all over 1 plus b minus ai times 1 plus b plus ai all over 1 plus b minus ai. Okay, sorry, plus ai. Now let's multiply. This time this will give you 1 plus b all squared. This time this will give you plus ai into 1 plus b. Okay, this time this will give you plus ai in bracket of 1 plus b. This time this will give you plus a squared into minus 1. So all over the first time, the first will give you 1 plus b all squared minus times minus a squared into minus 1. Yes. So I'm almost done. So if you clear this thing, you're going to have square the first one 1, multiply the first and the second one, double it, plus 2b, square the last one and have b squared. Okay. This and this will give you plus 2ai into 1 plus b. Okay, then minus a squared all over square the first one, multiply the first one and the second one, double it, square the last one, b squared, then plus a squared. Okay, so they said that a squared plus b squared is 1. If a squared plus b squared is 1, I'm going to have the imaginary part. Okay, if a squared plus b squared is equal to 1, so here is equal to 1, so I'm left with, let me bring the imaginary part is this side that has I. So the imaginary part of Z is only the side that has I, which is what? 2a in bracket of 1 plus b all over 1 plus b here. So 1 plus 2b here. All right. The part that has I, because this 2 is 1. So I'm left with this. So if you still clear the bracket, if you still clear this bracket, you're going to have 2 times this is what? 2a. This time this will give you plus what? 2ab all over what? 1 plus okay, yes, that is the answer. So this is the imaginary part. No need to do any other thing. That's the imaginary part. So that is 226. So 231, the last question I'm going to solve. Question number 231. And I'm done for complex number. 231. Question number 231 said let z1 be equal to 2 plus 3i and then z2 be equal to 3 minus 2i. Then I said then we should find z1 plus z2 bar. Okay, so z1 is 2 plus 3i plus z2 bar is 3 plus 2i. Okay, change the sign in the middle. So I have 2 plus 3i plus 3 plus 2i. So I have this and this is what? 5 plus what? 5i. So thank you very much for watching. Please like, share, and subscribe. Bye bye.